to be here. It's a pleasure to have Marius Karouzos here. He's a very remarkable astronomer. After his PhD in the University of Cologne, he was a postdoctoral researcher in the National Seoul University of Korea, and he has more than 41 papers published in astronomy. And nowadays he is a senior editor in the Nature Astronomy. So he's going to talk to us about how to publish and write an impactful paper in Nature Astronomy. So, Marius, thank you.
Thank you very much. Thank you, Eduardo, and thanks to Christina and Adriana for organizing this talk in kind of a short notice, and thank you for coming. So the idea, as you can see from the title, is to discuss how you can publish something in Nature Astronomy, in Nature, or in any other impactful journal. And my talk essentially has three parts. The first one is about Nature Astronomy, and what it is we are still kind of a new journal compared to the other journals in the field. Then I will talk about the process, editorial process in Nature journals, which is slightly different from what you may be used to from ANA or monthly notices and so on. And the last part of the talk is about how to write impactful papers, like hints and tips on good writing. So let's start with what is Nature Astronomy. And I'm sure all of you are familiar with Nature proper, the main journal, which has been publishing all kinds of science, including astronomy, for the last 150 years or so. This is actually the 150th anniversary of the journal this year. And if you have submitted papers to the journal, you probably interacted with Leslie Sage, who is the main astronomy editor for that journal. But what people sometimes don't know is that Nature also has field-specific journals, which we call Nature Research journals. One of them, for example, is Nature Physics. And of course, Astrophysics is part of physics, and therefore they publish also astronomy-related papers. We have Nature Geoscience, and this is, of course, more generally geoscience, but also includes planetary science that might be of relevance to geologists or geoscientists. We have Nature Communications, which is an open access journal, and it is like Nature in the sense that it publishes all kinds of sciences, including astronomy and astrophysics. And now we have a new journal, relatively new. This is now, we're in our third year of existence, Nature Astronomy. So what's the idea behind Nature Astronomy is, of course, that we want to follow the same editorial criteria as Nature and the same quality of published papers, but specifically and only for astronomy and astrophysics. The question that I'm sometimes asked is why? Why do you have this new journal? Does this mean perhaps that Nature doesn't publish astronomy anymore? This is not the case. So as you probably know, Nature is highly selective, so only 7 to 10% of all submitted papers to Nature are actually accepted. And this doesn't mean that the rest of the papers are bad papers or are boring papers. It just means that the competition to get published in Nature is really high, because you are competing with biology papers, with chemistry papers, with materials papers. And this means that a lot of really good astronomy papers are actually rejected. And this is the motivation behind Nature Astronomy, is to publish all this exciting, good science that cannot be published by Nature. And hence, Nature Astronomy. I just wanted to give you a very quick overview of the things that we have been publishing since our inception, just to show you the breadth of the topics that we handle So this is from our very first issue in January 2017, and it's an image you can see here. This is a cluster of galaxies that is undergoing a merger. There are observations in the radio and the X-rays, and you can see this kind of shock. And there are electrons that are ejected from a radio AGN being reaccelerated in this shock. And this was a paper by Van Weer and al. Showing this re-energizing of electrons in the intercluster medium. This is another paper. This is now a binary star, which was observed by ALMA. It is orbiting around each other. They create this kind of spiral wind that was observed by ALMA. And in this paper by Hussein Kim, they're trying to model this kind of spiral outflow and try to explain it. Completely different topic here. Here we have the comet 67P. These are all observations by Rosetta. And this is a heel that actually collapsed, and underneath the heel came out this pristine material that was observed by the spacecraft. And this is a paper describing this kind of the chemistry. This is a fun cover we did when actually Cassini died, when it plunged into the atmosphere of Saturn. We had an artist make this painting of Cassini orbiting Saturn. This is a black hole shadow. This was actually before the actual black hole shadow was published, the image. This was simulations of how we can use the shadow to differentiate between different theories of gravity. And indeed, we cannot, or that's what the paper said. This is another recent paper that we did. This is Bennu, observed by OSIRIS-REx. This was the first package of papers that was published by the OSIRIS-REx collaboration. That was they were all published in our journals. So I hope I gave you an idea of the breadth of topics that we are publishing, and I just want to show you now the structure of the journals, just to give you a better idea of how things work. Obviously, at the top you have Nature, the Nature proper, the main journal, and underneath it sit the Nature research journals such as Nature Astronomy or Nature Physics. Then you have Nature Communications, and then you have scientific reports. These last two bits of the pyramid are open access. This means that the authors have to pay some money to publish their papers, but then the papers are openly available to everyone. On the other hand, Nature and Nature research journals, you don't have to pay anything to publish as an author, but then to read the papers you need to have a subscription to the journals. As you can see from the arrow here, as you go up in the pyramid, the selectivity becomes higher. It means it gets more difficult to be published, but also the standards of the papers that are published are also higher. So the copy editing and the amount of work that goes into each paper from us, the editors, the copy editors, the typesetters, the art editors, increases as you go upwards. So now the question comes, I've shown you a number of journals that in principle can publish papers in astronomy, astrophysics, and planetary science. So a question that often comes up is, which journal do I send my paper? Of course, I want to have as high an impact as possible when I publish my results. And the first choice for most people is Nature, because it's the most famous journal. It gets the most exposure in the media. Your paper, if published in Nature, will be seen by not only your peers, but also all kinds of scientists and the public as well. But as I mentioned before, only 7% of the submitted papers actually get accepted. This means it's quite difficult to be published. If you do get published, of course, your paper will be sitting alongside some of the most famous discoveries in astronomy, including pulsars, the first quasar, and so on and so forth. But assuming that you don't want to publish your paper in Nature, or perhaps you've submitted your paper to Nature and unfortunately have been rejected, then you have a number of other options. As I mentioned, Nature Physics, Communications, Geoscience perhaps. And at the end of the day, your choice depends on the kind of audience that you want to reach. Obviously, if you're doing physics-heavy simulations of plasma in the sun, and you believe that what you find can be relevant for people doing plasma physics on Earth or in the laboratory, for example, perhaps you want to publish your results in Nature Physics. If you are studying a planet far away or nearby, and you're looking at the geology of the planet and you think that your results are relevant to someone studying the Earth, then perhaps you want to go to Nature Geoscience. On the other hand, Nature Astronomy aims to bring together astronomy, astrophysics, and planetary science. So if astronomy or astronomers and astrophysicists are your main audience, then Nature Astronomy would be the natural choice. So what are some of the advantages of publishing with us? Well, you are going to be interacting with people that are specialists in the field. We are all astronomers with PhDs and postdoc experience. We'll be handling your paper. And indeed, we only handle astronomy and astrophysics and planetary science. This means that your paper will not have to compete with something in biology or something in material science. As I mentioned, it's free to publish with us. You don't have to pay anything. And we are a high-impact journal. Disadvantages of Nature Astronomy, I had to put something here, right? So we're not open access. This means that someone will have to have a subscription to the journal to read your papers. But we do encourage archive submission of your paper. Therefore, the science will be out there. Okay, so this is a more formal breakdown of the things that we have been publishing. This is a thing after 2 years of publications. A nice pie chart. As you can see, we have roughly a quarter of the things we publish are related to planets and exoplanets. Then we have all kinds of stuff within the galaxy. We have the ISM, we have astrochemistry, we have stars, obviously the sun by itself, or the sun as a star. Then we have a large chunk of transients, and seems to be one of the most trendy topics currently in astronomy, including GRBs, especially with the whole gravitational wave angle. And then we have another quarter that is about galaxies and extragalactic things, including dark stuff, dark matter, dark energy, cosmology, and black holes, which is my personal favorite. So I want just to quickly do a rundown of the things that the type of things that you can actually publish with us, just to give you an idea. So first of all, we have the letters and the articles, and this is the bread and butter of all the journals. This is the things that you are submitting to us. And here the differentiation between the two is just in terms of length. Letters are shorter, articles are longer, you can have more figures for an article and so on. But then on top of that, and what differentiates us from the other journals, is that we have all the commission content. So here you can have comments, perspective, reviews, news and views. I will give you examples of this. You have mission controls, which is quite a bit interesting. So we do very short pieces every month, focusing on a new instrument or a new facility that is coming online or has recently come online and may not be familiar to everyone in the community. So we can do these short things. So we invite someone, the PI of the facility, for example, to write a short piece to sort of advertise or make the community aware of this facility. So indeed, if you have anything that you think should be featured here, send us an email, and the same goes for all the other stuff. And then we also have the editorial content. These are things that we write ourselves, which include an editorial, research highlights, which are short summaries of papers published recently in journals other than our own. And then picture stories are stories, again, very short, focusing on a picture, a nice picture that was published recently, maybe by Hubble, maybe by something else. This is an example of such a picture story that is actually from a paper from the Gamma survey, looking at the cosmic web using spectroscopy and galaxies, and they have this really nice looking picture, and this is a picture, and we also give a rundown of what is discussed in the paper. News and views. News and views are short pieces, maybe a page long, that actually accompany the papers that are published in our journal. So when we feel that the topic is of interest and the results could be interesting to people that are not experts in the particular field, we invite someone to write a summary and highlight the paper and discuss the context and convey the results to someone that might not be an expert in this particular field. Comments, as the name implies, are again short pieces that are opinion pieces essentially. We invite someone to write something that they think is timely. This was an example published a couple of years ago now by Wendy Friedman on this whole controversy of the Hubble constant, whether there's a difference between the early universe and the late universe. Then we have perspectives. These are longer pieces, maybe a few pages long, and this is again a bit subjective from a particular point of view, but discuss wider implications around a specific topic. In this particular case, this is Ellen Sadler discussing the future of astronomy in Australia, discussing what's the funding situation, what is the profession looking like in Australia. But this can also be something related to science, like for example, AGN, or what is a black hole, or something like that. We have reviews. This is what you know of, but they're usually shorter than what, for example, annual reviews does. It's maybe up to 10 pages or so. This is one written by Cristina Ramos Almeida from here on the obscuration in active galactic nuclei. And this is meant to be an authoritative piece of work that gives a full overview of a mature field in astronomy. We have meeting reports, and this is something else that is quite interesting. So an interesting conference happens somewhere. We invite one of the organizers or one of the attendees to write sort of a summary of the meeting, the highlights of the meeting, what were the main things discussed in the meeting, and we publish this. It's like around a page long, and again, this gives the readers an idea of something that has happened in the community. Perhaps they were not able to attend the conference. This is a way for them to see what's happening. We have more fun stuff. This is our books and arts section. This is essentially anything relating to astronomy as a tangent, let's say. So a book about popular astronomy, or an exhibition, or even a theater play, board games, anything really goes there, just to give an idea of what's happening in the community in a wider sense. We do special issues. We call them insights or focuses, and there we pick a topic. Here, example published in January this year, black holes, and then we commission a number of pieces like reviews, perspective, comments, and we bring everything together. We make a website, and it is meant to give an overview of the current state of a particular field. Finally, what I wanted to bring to your attention is our online community. You can see the link here. This is a free-to-access, free-to-read, free-to-write, sort of a blog or a forum where someone can go and write a piece about astronomy, about the work that they're doing, about a project in particular. We have different types of things that you can contribute. The most famous or popular one is behind the paper. This is essentially when a paper is published in Nature Astronomy or somewhere else, the author can come here and write a kind of background story of the paper. Like, how did they come up with the idea? What were some of the challenges that they faced before when they were writing the paper? Organizational things that cannot really go into a proper paper, but actually might be of interest to the community, especially to students, early career researchers. We have on the road, you're going to observations to Chile, you have some nice pictures, you're using a new instrument, you can describe this here. Now we'll just show you who we are. So this is our chief editor, this is Mei Chao. She has a background of physics, actually that was her studies, low temperature physics, superconducting, superfluids. But before coming to Nature Astronomy, she worked for Nature Physics for 10 years, doing the astro stuff for Nature Physics. And then she moved on to launch Nature Astronomy. We have Luca, and he's our planetary guy. He's an expert in all things planetary, including the sun and exoplanets. Paul, who is our astrochemist, he's doing ISM, stars, and some things within or close to the Milky Way. And then myself, I have an extragalactic background. I worked on AGN, and I'm doing anything beyond the local volume, let's say. All right. So how do you get published in Nature Astronomy or in Nature more generally? So this is a standard process that happens in most journals in the field, including ANA, UpJ, Monthly Notices. You have a paper, you submit it, the editor takes it, gives it to the referee, gets the reports, gives them back to you, and this is more or less it. Usually this is a nice way to picture the process. The difference is that now with Nature you have an editor, and it's controversial the way I've depicted myself here. Some would say I'm also one of these people. I think I'm not. Our role is to try and facilitate the process and make it as easy and as quick as possible so that hopefully everyone is happy, the paper is published, the referees don't have to do a lot of insane work, and the paper is accepted at the end of the road. What does this mean in practice? It means that when you submit a paper to us, then one of the editors is going to take it and read it and make an assessment of the paper before it is sent to referees. We are called to think about the novelty of the paper, the significance of the science that is presented, and based on that we make a decision whether we want to send the paper out to referees or to reject it without review. And this is why it is important that we are all specialists in our fields. We have PhDs, we have postdoc experience, we know our stuff. And assuming that we decide that the paper does go out to referees, then the process is more or less as you would expect it. The difference is that we have 3 referees per paper as opposed to 1 referee, which is the norm in most astronomy journals. But then we send the paper to the referees, where we get back the reports, and then our job is then to read the reports and make a decision based on them. This is more or less what editors in other journals do. Because we have 3 reports usually rather than 1, our job is more involved in the sense that we have to synthesize a single opinion based on 3 different opinions, and that's not always easy. But in any case, this is what we have to do. And then once the paper is, it's decided that it's going to be published, then we do extra work in the sense of we go in the text, we help you improve the abstract, we help you improve the figures. We have art editors that are working with your figures to make them look prettier and be consistent within the journal, and so on and so forth. What do we look for as editors when we are looking at a paper for the first time? As I mentioned, the novelty is the first, let's say, hurdle you have to pass for us to consider your paper for publication. And this doesn't mean you have to reinvent the wheel to be novel, but we have to be able to see that compared to the previous papers published in the same topic, you are going a significant step forward. We are learning something new compared to what we knew before. Of course, we also like to see a logically developed paper, a nicely written paper, a nice figures that communicate the result in the optimal way. We also do hate to see overhyped papers that are trying to sell things that are not really supported by the things inside the text. But these are all secondary with relation to the significant advance, which is the main thing we look for. Here you can see the differentiation with the referees. So once we believe that the paper is novel and interesting enough, then the referees are called, first of all, to confirm our initial assessment that indeed the paper is doing something novel, something new. But of course, then they also check the technical part, the actual science, that what you're doing makes sense. You've analyzed your data correctly. You've done your simulations as you should. Your conclusions are original. There wasn't a paper 50 years ago saying the same thing. And another important thing is we ask the referees whether they think your result is relevant to a significant cross-section of the community. It's often the case that you have something very new, but it's only relevant for like 5 people in the whole community, like you and your collaborators. And this is not the kind of papers that we want to publish. We want to publish things that will be relevant and interesting to people as widely as possible within astronomy, not biologists, but we do want to have this kind of wide relevance. Now, the question is, how long does this take? This is something that people are worried about. Initially, from our part, we say that we promise to give you our own assessment within maximum a week, of course, depending on whether I'm in Tenerife giving a talk and not on my desk, or whether people are on holiday. But this is our benchmark, no longer than 1 week to make the first assessment, whether we send referees or not. And then we ask referees to return the reports within 2 weeks. But of course, they are humans, and usually they don't stick to the deadlines. So I'm not saying anything. But so ideally, within a month, you should have a first result, assuming that the paper goes out to referees. But more often is the case, around 5 weeks is a good rule of thumb for this. What if you don't agree with the decision? So as I said, we do reject a large chunk of papers without sending them to referees. And we are humans as well. So this means that we may make mistakes or overlook something. You are more than welcome to appeal our decision. And it happens. And sometimes we do change our opinion. And when you do this, it's helpful if you do this in a proper way. So you can send an email and tell me, you overlooked this paper or you didn't understand this argument, rather than telling me, this famous person really likes my work, something like that. Now, of course, if you want to appeal a decision made based on referee reports, that's a bit more difficult, especially because we have 3 referees, and if the consensus is that, this is not a good enough paper, then it's very difficult for us to think that, all 3 referees are wrong and, you are right. But it has happened as well that, some cases, because when you have 3 referees, it might be that 1 referee is very negative, 1 referee is very positive, 1 referee is somewhere in the middle, and then we have to make a call. And in some cases we say, okay, we think that the consensus is negative rather than positive. In those cases, perhaps you have grounds to appeal, and then we may call in a 4th referee and ask for an independent opinion to see, where the ball falls. All right, so we have some services to the authors which I want to highlight. I think the most important one is the pre-submission inquiry, exactly because this is a long process. It takes effort to publish. We have a different format than other journals. So we want to help you save time. And what this means is that you can send us an abstract or a summary of your work along with the 1 or 2 main figures of your results, and you can ask us what is our opinion. And based on this information, we can tell you, yes, this is very interesting, please do submit the paper, or no, we don't think this is within our scope, or we don't think this is novel, or it might be that we don't have enough information. We'll then ask you more questions or something like that. If you have a draft written in your favorite format, which might be ANA, APJ, monthly notices, you can send this to us in that format, and we will read it and make a decision based on that. One thing I should point out here is that we have length limits which are different from the main journals. So a 40-page paper will not be able to be published with us. Maximum, let's say maybe 10 pages is okay. So it can be in ANA format, but the length should be comparably similar to what we are looking for. Otherwise, it's very difficult to make a decision. We have manuscript transfers. This means that you can aim high, go to Nature first, and then maybe you get rejected. Then you can transfer everything to us, and hope for a better solution of the problem. This also means that if you go to Nature and your paper is seen by referees, if you transfer, we can get all this information, and we don't need to restart the process. We can just continue from where you left off with Nature. And there have been times where the referees at Nature said, this is very interesting work, it's technically sound, but it's not as novel as Nature requires. And then the paper was transferred to us and was published without any other issues. I mentioned the post-acceptance support. This means all the work that we as editors put in your paper to improve the abstract, the text, the art, and so on and so forth. And then, of course, you have press and publicity. We have a press office that advertises results to both expertise, venues and media, and also to the general media, to newspapers and so on. We do our own press releases for a number of the papers we publish. And, of course, this provides amazing visibility for your results. The final thing for this section I want to mention is the Shared It, and this is something also that people may not know about. This is a service we are offering to the community for people to access papers for free. They can read them for free, but they cannot download them to their computer, they cannot print them out. How does this work? If you are an author, so if you have published a paper with us, or if you have a subscription to the journal, you have this link at the bottom of the paper, which you can copy-paste and you can share, and whoever clicks on the link, they can read the paper for free, but they cannot download it, they cannot print it. You can put this link anywhere. You can print t-shirts with the link. You can put it on your website, on Twitter. You can put it on the archive. So in many cases, people submit, on the archive, the initially submitted version of the paper, and once it's published, they can put this link as well, and then everything is in one place, and you have maximum, dissemination of the results. All right, so this brings me to the last part of the talk, which is about how to write an impactful paper. And I always start this part by saying that there are really, really many papers out there, and many more are coming out every day. These numbers are already obsolete. I think they are a couple of years back. 60 million papers on the Web of Science, more than 1 million articles on the archive, hundreds of new papers coming on the archive every day. This is a curve. The curve showing the exponential increase of stuff on the archive. This is a study from ADS that was published last year, showing again the steady increase of published things on the internet. So I like to see the archive as this kind of place full of papers, and of course when you publish a paper, then this is just one more in a sea of noise. So the question is, how do you make yourself, your paper and your research stand out of all the noise that is around? You do this by obviously having a great paper, and what does a great paper mean is obviously you find a great paper at the cross-section of these three things. You need obviously good science, and this is not a problem. You are all good scientists, you're doing exciting stuff. But you also need good writing, and you also need good plots. Both of these things can be challenging and are often problematic and can often be obstacles to the people, the researchers, first discovering your work, second understanding it, third actually using it in their own work, citing your paper. So what is a great paper? What should be a great paper? A great paper should be essentially the culmination of a project. I understand and I know that nowadays, we need to publish as much as possible, publish or die, or publish or perish is the word. But of course, you can understand that if you have a project, you divide it in 1,000 pieces, then the impact of each one piece will be 1,000th of the whole thing. So it is good to try and present a concise and full, a complete image of the project, the start, the middle, and the end, what are the final results, rather than giving it piece by piece. This is very important. You need to pay the same level of attention that you do to your analysis, your observations, your simulations, that you give to writing the paper. It doesn't make sense that you spend hundreds of hours observing with a telescope and then spend half an hour to write a paper about it. You really need to put the effort and the attention to write a good paper. What is not a great paper? Well, in principle, it shouldn't be a paper that you just write because you need one extra line in your CV. And of course, if you see writing as a chore, if you feel yourself bored and say, oh my God, I have to write a paper, then this kind of sentiment comes through to the reader, and similarly the reader will be equally bored with you. So one thing you always have to think about is who is your audience. I find this is a very common problem. People make assumptions about who is reading the paper, or they don't think about it at all. So obviously when you publish a paper in Nature, your audience will be all sorts of people: astronomers, non-astronomers, the public, and obviously you have to write with that in mind. When you publish in Nature Astronomy, the audience is of course narrower. They are specialists, they are astronomers, but still you have to think. I mean, if I want my result to be read and understood by someone who may not be my collaborator, then I need to be able to expose the knowledge that is necessary for them to understand the result. So this means, of course, you need to explain the things you're doing, you need to explain the logic behind your work, but at the same time you shouldn't be too wordy, you shouldn't give too much information that may actually drown the signal into the noise. You need to be realistic, and this is another problem that we often see as editors. You have an abstract that promises everything. We are finding the final answer to all the questions. You don't need to do that, especially if you don't provide the answer to all of the questions. But instead you can be realistic. You can say, this is a specific question I'm asking, and this is a specific answer I'm providing by the end of this paper. Don't hype your paper, yes. Feel free to speculate. I say this here. This actually applies to us. I think Nature proper doesn't really like speculations. They really like clean-cut results and interpretations. But we are a specialist journal. This means there is more room to speculate, to discuss implications and outlook, as long as these are clearly labeled as such. So you say, these are my results, this is the immediate interpretation, and now I'm going to discuss potential things that may come off based on my results. Think that everyone is busy. You are obviously really busy, you have to write all the papers. The referees are extremely busy, they have to read all the papers, and then the readers are obviously even more busy because there are hundreds of new papers there every day. They have to understand what is relevant to them, read it, and so on. So essentially these days, an impactful paper means actually a paper that has been read by one human being that is not in the author list. And this is not a given. I mean, there are papers that are actually never read because there are so many of them. So you do need to think about this time investment from the side of the reader, and you need to be able to convey all the information as quickly and efficiently as possible within the 5-10 pages of the paper you're writing. Which brings me also to the point that if you write a 40-page paper, probably no one is going to read it. So try to be a bit more succinct with the way that you publish things. Okay, so how do you do this? You need to transfer information very quickly. And journalists always say, start with the news. This is a very valuable lesson. And what this means for paper is essentially the title. You need to have a punchy title that gives the main point of the paper in as few words as possible. And how do you do this? You obviously avoid open-ended titles. I personally don't like questions in the title because obviously I'm reading a paper to know the answer, not the question. Never use acronyms in the title, jargon, abbreviations that people may not know what they mean. And I also recommend people not trying to be witty or catchy with the titles because usually, first of all, it doesn't work. Second of all, you are having an international audience which may not be able to understand the particular witticism that you're trying to make with your title. So although it is more boring, I do recommend that you try to be very matter-of-factly about the title and give the main result, blah, 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 something. We find it. Once someone reads the title and they understand what the title is about, they understand what is the main result of the paper, then they're going to read the abstract and try to understand whether they want to actually invest time and go into the main paper and read it more carefully. This means that the abstract is the main gateway to the paper, and it is really the most important part of your paper when it comes to communication, at least. I will put this all up. So this is kind of the breakdown of that we recommend for an abstract. And as you will see, 40% of it we say should be the context. So don't start off saying, we find this and this and this and this. Because if someone is not familiar with the field or what are the questions, then they will be lost immediately. Why should they care? So first of all, start off by saying, this is the main topic. These are the open questions, or until now we knew this, but we wondered about that. So now we are going to answer this particular question. You can spend maybe one sentence describing the actual method, like maybe I use this simulation or I use this telescope, but this is not really the main point that you want to convey. Obviously, you're doing something. They can read the paper for the details. The other 40% should be the results, obviously. This is where you really explain to the reader, what are the main findings and, what is the analysis that you performed. And most crucially, the last 10%, one sentence, two sentences should be the implications of your results. Again, this is kind of like mouth feeding, like giving the food to the reader as easily as possible. Why should they care? If you stop here, then the reader has to go through the process of, okay, they find this, they find A, so I'm doing C, and there's this B, so maybe that's why it's relevant to me. If you put this last 10%, you say, this is relevant because blah, 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 or based on this, then we can think about that. This is already, it's the hook that will essentially bring the reader inside your paper. As in the title, again here, you need to avoid any kind of jargon, any kind of abbreviations, assuming that, of course, you want to reach a wider audience. If you just want, the super experts to understand the paper, then that's completely fine. You can do this. But for Nature Astronomy, and definitely for Nature, we don't want this kind of language. So assuming that everything has worked perfectly fine, and you have had, a nice title, you have had an informative abstract that, draws the reader in, then it's time for you to write the actual paper, and this is also not easy. So we do recommend that, first of all, you just write down a list of bullet points of the main things that you want to discuss in the paper. What are the main results? What are the main plots that you want to show? And then based on this list, you can start to flesh out the paper. What are the sections you may want to have? What is the order of the things that you want to discuss? One thing that you have to keep in mind, many people tend to use the chronological order. So we did this, then we did that, and then we did that, which is not necessarily the best way to tell a story, as the Americans like to say. Sometimes it is okay to change the chronological order to make things more easy for the reader. So think about what is the easiest way to explain the process and the result, rather than actually the order in which you did things. Do not pad the main paper with superfluous information. Keep in mind, again, what is the specific question that you're asking, what are the pieces of knowledge that are necessary for the reader, and then write your introduction and so on based on this. But at the same time, of course, you don't want to leave out anything important. Don't assume that the reader knows everything. Don't assume that the reader is within your head, knowing your thought process. Something very interesting, and I think something that is very relevant, is becoming even more relevant every day, is the fact that reading papers nowadays is completely non-linear. So you will not read the paper from beginning to end. You will read the title and the abstract, and you will go in the paper, read the results, look at the plots, maybe go to the methods. So you have to make this possible for the reader as easily as you can. And this means signposting. This means using keywords that will let the reader know, or key phrases, that now you're changing topics, now you're focusing on this or that. For example, for our papers, the caption of the figures always has a first sentence which is short and summarizes the whole thing. What is this figure showing? I don't have to read through the whole thing and look, okay, this is this line, this is that line, to understand what is being shown. I just read the first sentence and I know, is this relevant to me? Yes. I read the rest of the thing. Maybe it's not. I move on. Yeah, this is the title of your figures and tables, able to quickly navigate through the paper and get the information you need as quickly as possible. Which brings me to one of the last points I want to make, which is usually also a point of discussion about the Nature papers, is a different format. And people are scared by that, but it really is not that different. In the standard paper, you usually have an abstract, You have an introduction, methodology, you have the results, discussion, conclusion, sometimes the summary. How is it different to Nature Astronomy? Well, if you're writing a letter, which is the most common format for papers in our journal, you have a first paragraph in bold, which is both part of your text, is the first paragraph of your text, but also function as the abstract of the paper. So this means all the things I told you before about the abstract apply here. You need to have an introduction within this first paragraph, the context, the main results, and the implications. Once you're done with this, then you move on directly into the work that you've done. You have a small paragraph about maybe the methods that you use or the instruments, and then the main bulk of the paper is the main results. This is where you discuss your findings, you show your plots, and then you can have perhaps a short, a few paragraphs on discussion and perspectives. We don't want summaries because anyway these papers are quite short, and we don't want discussions that are going on and on and on for pages. Once you've done this, this is the main part of the paper, you will have the list of references for the main part of the paper, and after that you will have your methods. So the methods is essentially this part, the methodology, and there you can put all the nitty-gritty details of your work, the software you use, the mass resolution of your simulations, the grating that you use for your spectrograph. All these things can go here, and in this way the motivation behind this kind of structure is that we want to put all the weight on the results rather than having the methods in the middle of the paper where potentially might confuse the reader that is not a super expert. But this is still part of the main paper. It's in the same PDF file, or if you're not using PDF, the same HTML page. And this means that if you're now expert, you read the result and say, okay, how did they actually do this? Then you can quickly click the link, go to the methods underneath, and see the relevant things. And in this way, we do feel that the focus of the paper is the results and not the actual details. Okay. So this brings me to my last slide. You've done everything beautifully. You have an amazing title, a good abstract, a well-defined, structured paper. Are you done? Are you ready to send your paper to us? I would say no. First of all, we do recommend that you leave your paper, aside for a couple of weeks at least. Do other things. Everyone has a gazillion projects. You're writing 50 different papers at the same time. You can afford to wait for 2 weeks. And then go back to the same paper, read it again, with fresh eyes, fresh mind, and see if everything makes sense still, if you haven't missed a paragraph here or, a line is not there. Print out your paper, find a quiet room and read it, line by line, preferably with a pencil or pen, and trace the lines and read it. This is how you are going to see whether, indeed you look at the green line and there is no green line, it's actually a blue line or something like that. Or points are missing, or there are spelling mistakes. And these are actually trivial things which can be fixed and will be fixed. Like at the end of the process, we have the copy editors that are going to fix the language, we have the art editors that are going to fix the figures. We editors are also checking all these things. This is fine. The problem is the first impressions. When you send a paper to the referees and they see misspelled words, they see something missing here, they see a missing reference, all these things make it difficult for them to have an unbiased opinion of your science. Because we are all human creatures, first impressions do count, and if the first impression is sloppiness, then it's easy to assume that your science is equally sloppy. I mentioned that the abstract is the most important part of the whole thing, because it draws in the readers. So we do recommend that you send your abstract to a couple of colleagues, which may not be experts in the field. They are still astronomers, obviously. And ask them, what they think is the main result of your paper, and you may be, surprised to see that they actually come up with something different from what you had in mind. And this is not because they are stupid or because they didn't pay attention. This probably is because your writing can be improved and made more precise. The last recommendation comes from my Max Planck days. In the Max Planck Institute, usually we always have an internal referee to papers before they actually go to the journal. And this is an expert in the field who is not a co-author, obviously, who reads the paper from scratch and gives actual, comments about the analysis, about the results, interpretation. And I do understand that this step takes time. It can add considerable time to the whole process because obviously everyone is very busy. But again, the idea here is that you have a friendly colleague who in principle wants to help you and not destroy your career. Look at the paper before the referee who is impartial, who doesn't know you, who doesn't care, whether you get your grant or your position or something. And it's far better for this person to find a problem with your analysis than for the referee. And then, yeah, once you've done all these things, then do go ahead and submit your paper to Nature Astronomy. And that's what I wanted to say. I want to point out and stress that unlike other journals, we are full-time editors. This means that we are there for the authors. This means that you see I'm here, I'm giving this talk, I go to conferences, I talk to you, I exchange emails with you. This is my only job. I don't do any research of my own. This means that we are always happy to communicate. If you have ideas about pieces that you want to write, if you have research that you think might be relevant to us, if you want to pitch something to us, then do send an email. You can see my email here. Then there's also the general email of the journal. And of course, we are active on social media. We have Twitter and so on. So yeah, thank you very much for your attention. And if you have any questions, I'm happy to answer them.
Thank you, Maros. Is there any question?
Hi. It was not clear to me whether all the other content, except for letters and papers, so this means review, if all of them are by invitation, or people can also suggest?
So usually they are by invitation. So usually it's our job to have an overlook of the field, and they decide, okay, this is a timely topic, I want to invite an expert. But obviously, if you have an idea, because obviously we're not experts in everything and we don't know everything that is happening in the community, you can come to us and say, look, I think this is a very interesting question and I would like to write something about it. And then of course we will have to think about it and check and come back and say, yes, we think this is a good idea, or maybe, perhaps, and so on. But yeah, we are very open to suggestions.
I have two short questions. The first one is, I don't know if you mentioned already, if you expect from the authors to send to you the main abstract or the main part before start writing the paper.
No, this is not.
This is the way we do with Nature. I mean, the main Nature. We typically, Leslie typically says that if we prepare an abstract and send it to him, he may figure out if the paper will be interested or not.
I think he likes it that way, but in no way is it necessary. It makes things faster, because then especially for him, because he has to reject the vast majority of the papers. It is way faster for him to just check an email with a few figures and make a decision, rather than having a whole paper in front of him. But I think for us, because like half of the papers that we get are sent out to referees, I think it's not really necessary. It can save time for you, perhaps, to make it just faster. So we say we are welcome to do it, but it's not necessary.
And the other thing is there, before in the past, I had the experience that a paper sent to Nature, there was a direct connection to APJ letters. If the paper was rejected, for instance, by Leslie Sage in Nature, and evaluated by referees, maybe, the paper, Leslie used to have the direct connection to APA letters somehow, and offered to the authors to use it. I guess now this is not done anymore. I don't know. Maybe the paper is offered to be transferred to Nature Astronomy. Is that the?
I think it's completely up to, I guess Leslie makes a decision whether he thinks that the paper is fit for Nature Astronomy, or he thinks it would be better fit to APJ letters. Leslie does know everyone. He's been doing the job for like 20 years. So I think it's just a service to the authors that he can try and take the reports and so on and give them to the APJ letter editors, just to make things easier. And we're happy to try to do it as well if it comes to that. Like if we want to send the paper to APJ letters after it has been reviewed for us, we can try to do the same thing. But it's completely up to the referees and the editors to try and set this up to just expedite the process.
Okay, and last thing. What is your opinion or the real statistics related to the impact factor of Nature Astronomy compared to APJ letters? Okay.
So our impact factor was just released actually late last month. It's 10.5. APJ letters is I think 8.8.
Okay, thank you. Nature itself, its policy about publishing an archive is after the paper is published.
No.
No?
This is a very common misconception, which is not true. So you can put your paper in the archive at any time. The originally submitted version of the paper, so the one that you submit to us, you can put it in the archive. It can already be in the archive and then send it to us. It's completely fine.
Oh, okay.
What we say is that if you want to put the final accepted version of the paper, so the one before like the final acceptance, then this can only go in the archive 6 months after the publication of the paper.
Mm-hmm.
But otherwise, the originally submitted paper can go at any time.
Okay, and it's the same policy with Nature Astronomy?
Yeah.
Okay, great, thank you.
A clarification about this. When you say the last version, you mean the one already in Nature Astronomy format,
No.
or even
So-
the author version?
So the final version, the one that will be published on our website, so the PDF file that is in our style, this you cannot put on the archive. This is proprietary thing. But the thing that the author version that you submit finally after all the revisions from the referees and so on, the one that is accepted, this is the one that you can put on the archive 6 months after the publication.
Okay, but then, for example, if the original paper was already on the archive, then you are suggesting to add the link.
Yeah, you can if you want. Yeah.
That would be the thing.
Yeah.
So you mentioned that to be published in Nature Astronomy, your results have to be a significant advance. How, in general sense, how would you define a significant advance? Because I mean, everything is based on something which has come before. Most results, right? So
it really depends. So, for example, there are cases where, someone had a sample of 10 galaxies looking out there or whatever, and they find some initial results based on this sample. They say, they find this result A, and then they have a sample that is 10 times larger, and they still find the same result A, but maybe with slightly better significance. Then this is not significant for us. Something I see very, very commonly, especially in the solar community, about the heating of the corona and looking at like this nanoflares and so on. And we see this nanoflare, and then there is another paper that is the nanoflare is slightly, the resolution is slightly higher, and then it's even more robust evidence that this is the way to heat up the corona. Again, this is not significantly new. At the end of the day, it has to be an assessment from the editor based on what is published already, to try and figure out, how significant is the advance. There is no clear-cut answer to say.
Sure. Okay, thanks.
I should also point out that in terms of significance, 3 sigma is probably okay for us. I think Nature likes 5 sigma more, although there have been some 3 sigma results. But I think for us, robust 3 sigma is fine.
I think you didn't mention what is the rejection rate of Nature Astronomy?
So I would say what's the acceptance rate, because it sounds nicer. The acceptance rate is 25%.
25
Yeah.
acceptance rate.
Yeah.
Okay.
Overall. So roughly it's usually half of the papers are rejected without being sent to referees, and of those sent out to referees, half of them are rejected by the referees.
Is there any more questions? No. Yeah.
Thank you. So about the periodicity, the period nature. So right now, Nature Astronomy isn't by period, right? It's not. It publishes whenever its papers. It has enough papers, right? Or
No.
does it publish every month?
Yeah. We have so we are a monthly journal, and actually content is published every week online, and then we put everything together into an issue every month.
Yes. Thank you.
So, thank you everyone for coming today, and thank you. Adios.
Well, thank you.
Ciao.